Okay, let me present chapter 5 functions. So far, we have used many built-in functions such as cosine, cosine d, sine, square root, max, min, and so on. The functions are predefined by the system, so they are built-in functions. In this chapter, we'll learn how to define functions by ourselves. The objectives of this chapter includes how to define a function, how data are passed into a function. So what is the data passed into a function? In your homework 1, I believe you answered the question, what is the difference of cosine and cosine d? So cosine, the data passed to the function is a radius, such as pi, negative pi, 2 pi, pi divided by 2. Cosine d, the data passed to the function is a degree, such as 30, 60, 180. The data passed to a function is called a parameter, or called argument, or parameter. Next one, how to return data including multiple results. Some functions return one result, some return two values. Some functions, for example, square root return a value, sine return a value. Some functions such as max, it return not only the maximum value, but also the position of the maximum value. How to include other functions not needed except as helpers to your own function. Before I talk about function, let's see some concepts. First one is abstraction. Procedural abstraction permits a code block that solves a particular sub-problem to be packaged and applied to different data inputs. So a code block is actually the implementation of the function and different data inputs. For example, sine, you can accept different values for the input. Sine pi divided by 2, sine 2 pi. Encapsulation is the concept of putting a wrapper around a collection that you wish to protect from outside influence. You write something into a function, and then the implementation in the function are enclosed inside the function. So other statements have no impact to the function. For example, when you write a function, inside the function you use variable a, b, and c. Outside the function, when you write a script, you use a, b, and c. So the scripts a, b, and c have no impact to a, b, and c in the function. Black box view of a function. A function has some inputs. The inputs are called parameters. You see parameters 1, 2, 3 to n. So a function can have 1 parameter, 2 parameters, 3 parameters, or many parameters. When you write the function, the functions are called, the parameters are called formal parameters. So they are formal parameters. When you call the function, you type some numbers, some Boolean values, so that is concrete values, or you type the variable with the variable assigned something before. So what you need to type into the function are called actual parameters. The particular implementation inside the function is in the black box. That is, others can use your function, but they don't know the concrete implementation of your function. They just use your function. MATLAB function implementation. If you write a function in MATLAB, you use the template. The template is the function return information, function name, and then parameters. Inside the function, first one, documentation. This actually is the comment. It is not necessary. Code body. The code body is very important. It is a description of how to implement the function. The function must return a value. So how do you return a value? The value is returned by an assignment statement. So you assign something to return information to the, so that is to return the value. The function code must be stored in a file whose name is the same as the function. For example, if your function is cosine d, and then the name of the .m file is cosine d. So cosine d is the built-in function. You don't need to write cosine d again. I just use the identifier as an example. If you write a function, it is a cylinder 1, you want to calculate the volume of a cylinder. So if your function is cylinder 1, and then when you save your .m file, the name of your .m file must be cylinder 1. You cannot change the name. So it is different from regular scripts. In regular scripts, you can save your scripts as, for example, lab 1, homework 1, any name, or even untitled one. But when you write a function, the name of the function and the .m file must be the same. Functions return data to the caller by assigning values to the return variable. So you need to assign something to the return variable. Functions throws an error if a function does not make assignments to all the return variables. You have some return variables, but you don't assign values to all the return variables. If you call the function, you will see some errors. Okay, next one, let's see an example. The example computes the volume of a cylinder. So you know a cylinder. Okay, the cylinder has the top shape and the bottom shape. They are two circles. The circle has a radius, and the cylinder has a height. So in mathematics, the area of the circle is pi r squared, and the volume of the cylinder is the area times the height. So if you have a cylinder, the area of the base or the top is pi times r squared. This is this area, and then times h. So this is the volume. You can add a parenthesis or leave it out. It doesn't matter. But if you add a parenthesis, it's more clear. So this is volume. We want to implement the formula to a function because we will use the function many times. So we write this to a function. In the function, okay, according to the template, the first one is reserved word, the function, and then return information. We return volume, and then equal, and then the name of the function is cylinder 1, and then parameter list. It has two parameters. One is height, second is radius. And then you add the documentation function to compute the volume of a cylinder. Volume equals cylinder height radius. The documentation is the comment. The area of the base is pi times r squared. This is base, and then volume is base times height. So this is to compute the volume of the cylinder. So how do you write a function to MATLAB? This is a program. This is the code of the function in MATLAB. Okay, you create a new script in editor window. and then save. You see, when you save, you see the default name is cylinder1.m. It is not such as untitled 1. You save, okay, the name is cylinder1. The name of the function is also cylinder1. So you have the function. How do you call the function? You have two ways to call the function. For example, if you have a function sine d, how do you call the function? You can call the function in the command window sine d 30 degrees get 0.5, or you write a program in the program you call sine d 30 degrees or sine d x. So how do you call a function in MATLAB? You have two ways. First one, you type the name of the function and then you type the parameter, for example 10 for height, 3 for radius, and then you get 282 point something. The second one is to write a program. In the program you call cylinder1 and then with two parameters. So this is a simple function. You learn function is totally a different concept of programming. You have the experience to write some regular scripts, such as you write a script to compute the results by mathematical formula in chapter 2. You write a program to handle vectors and arrays in chapter 3. You write a program to use a for loop, while loop, if statements, switch in chapter 4. All the programs are scripts. In this chapter, you write a function. Function is different. There are some common mistakes because someone has the habit to write regular scripts. So when you write a function, try to avoid the common mistakes. For example, if you are asked to write a function cylinder1, someone writes a function like this: function volume equals cylinder1 height radius, and then height equals input, please type height, radius equals input, please type radius, and then base equals pi times radius square, volume equals base times height. So first one, normally when you write a function, do not incorporate input or output in a function. This is encapsulation. The value in the function are transferred from the parameters, but not by input. If you add input, the function is not a function. It becomes regular script. So first one, do not add input or output to your function. Second one, the name of your function must be the same as the file name. You save the function, then the name is the same as the cylinder1, the name of the function. If you save it to a different name, you cannot call your function. 3, add a semicolon to hide the display of variables in the function. So in the function, you compute something, add a semicolon, don't display anything of the function. The function just returns something. Return is the output. You don't want, so the user who calls the function don't want to see the values in the function to be displayed on the screen. So add a semicolon. Next one, do not use clear or CLC in a function. CLC and clear is used in a script. So when you write a complete script, at first you add CLC or clear to clear up the command window and the workspace. So you start over to run your script. But when you write a function, do not add CLC or clear. Suppose you write a function, you add clear or CLC. Then when you write a script, the script calls the function. Before the script calls the function, there are many statements: assignment, computation, and something else. And then when the script calls the function, if the function has clear or CLC, everything before the function will be cleared up. So do not use CLC or clear in your function. If you use clear or CLC, that is to write a regular script, but not a function. 5. Parameters must be consistent with arguments list. So if you write a function, you write the arguments list, that is the parameter list. So here, for example, the two parameters are height and radius. They are two numbers. So when you call the function, use cylinder 1, 10, 3, the two parameters. If you use one parameter, the calling is bad. If you use 3 parameters, the calling is invalid. If you use 2 parameters, but they are 2 Boolean values, or 2 strings, or 2 vectors, they are invalid. So parameters must be consistent with the arguments list, meaning the numbers, so the number of the parameters must be equal to the number of the arguments list. For example, here, 2 parameters, 2 arguments list. Second one, the data type must be consistent. So there are 2 numbers. When you call, you use 2 numbers. So both how many parameters and the data type of the parameters must be consistent with what you define in your function. Let's see one more example. This example returns 2 values. The example is a cylinder. Cylinder has 2 parameters, height and radius, and the cylinder returns the area and the volume. The area is the side area plus the area of the top circle and base circle. So if a function returns 2 values, you need to use brackets to enclose the 2 return identifiers. If a function returns just 1 parameter, you don't need to use brackets. If you add brackets, that's fine. But normally, if a function returns just 1 value, we don't add brackets.